and what we're going to do here today. So hopefully we are all here at this example. This is more of a kind of a generic one. We'll get into one that's a little more easily seen to be applicable here in just a second or a few minutes at least. So let's read this over real quick and decide how we're going to handle this. It says use the graph of f prime to find the absolute extrema. Then the instructions down below say find the absolute extrema, so that's min and max of f of x, given the graph of f prime and that f of negative 2 is equal to 3. So this is similar to one we did yesterday, but it was not presented as a graph yesterday. Similar in the fact that I'm giving you a lot of information about f prime, but then I'm asking you about f, right? So if I ever do that, if anybody or any test ever says, here's a bunch of stuff about f prime, now tell me something about f, what has to be involved in there somewhere? An integral, right? An integral has to be in there. If I'm giving you information about f prime, but I want to know stuff about f, you've got to use an integral in there somewhere. So what I thought I would do here is approach this really from a chapter 3 perspective at the start. We'll finish at a chapter 4 perspective. So here we go. Absolute extrema, key word right there, or keywords, that's what we're looking for. Can anybody remind all of us, what are the candidates for absolute extrema? Zach?
Critical numbers and endpoints.
Critical numbers and endpoints. Remember this? This was really not that long ago, from chapter 3, critical numbers and endpoints. So let's see here. Critical numbers, let's say endpoints right here. Endpoints would be negative 7 and 8. And then how is it that we are supposed to find critical numbers? The critical numbers of f happen whenever f prime is 0, or perhaps undefined. F prime looks nice and continuous here, so I would say that at least for our interval, f prime is defined for all of the domain. And so f prime equaling 0 would be what we're going to look for here. So how many places does f prime equal 0? 3 of them, yeah. So I would say critical numbers would be negative 6, negative 2, and 4. So those 5 numbers are our candidates, and so those are going to be the only ones that we have to consider. And of the ones we got to consider, don't we already know a lot of information about one of them? Which one do we know a lot about? Yeah, we know that f of negative 2 is 3. We know that from the start here. So what I'm going to do, we did this in chapter 3 with absolute extrema. I am going to make a little table. So here's my table. Here are my candidates listed off to the left. We're going to go negative 7, negative 6, negative 2, 4, and 8. So those are all 5. Those are all my candidates. And there's my y. And as you just mentioned, isn't there one of them that I could put the output in right now? Yeah, when x is negative 2, y is 3. So I really only have to do analysis for 4 of the 5 to get an answer here. And I wanted to kind of set this up for you and show you the connection to yesterday, and then I'll let you guys do the other ones to see what actually happens. So I hope that this looks really familiar from what we did yesterday. I'm going to just start doing some work off to the side here. Here we go. I'm going to say this. The integral from negative 7 to negative 2 of f prime of x equals, I'll pause right there for a second. We'll write down what it equals in a second. Why on earth, you understand why I would do the integral of f prime because I want to know f, but why on earth would I pick negative 7 and negative 2 for my limits on my integral? Why? Did I just pick those randomly? Did I pick them for a reason? And if so, what's the reason? What do you think? Zach? I already know the output for negative 2, don't I? Well, why would I include the negative 7? That's one of the ones I want, right? So if you're going to set these up, the 2 limits on your integral, one of them had better be one that you already know, and then the other one had better be one that you want to know. All right? So I'm not going to do like negative 5 to negative 2 because I don't care about negative 5 for an output, for an input into f, but I do care about negative 7. All right, so as far as what this equals, does this look familiar to you guys from yesterday? F of negative 2 minus f of negative 7? We did that a couple of times yesterday. We're using FTC2 and FTC1 together there. We're saying essentially that the integral, the definite integral of a rate is equal to the net amount of change. So On the right side, I know that f of negative 2 is 3, so I'm going to put that in there. And then I've got this f of negative 7. But then I've got that integral on the left. And there's a number of strategies you could take with that integral on the left. Can I tell you the worst one from a time perspective? I mean, the worst one would be just simply not knowing what to do. But if you were going to take a correct strategy, but a bad strategy, like one that would be unwise, I've seen this done. I've seen folks on the AP test say, you know what? That looks like a piecewise linear graph. Looks like 3 line segments, right? I've seen people that have decided, I'm going to figure out the equations for those 3 lines.
Oh, geez.
But it's not that hard to do, but it takes a lot of time, a lot of space. You're going to figure out the equations for those 3 lines, and then kind of piece it out, right, in little chunks, and actually do, find the antiderivative and plug in the negative 2 and the negative 7 and subtract and go through a lot of time and a lot of effort. That way, eventually, if you do it all correctly, will work. It definitely would work. Don't do it that way. What should you do? I think I said this saying before. Have I ever said this saying, if you can't integrate? I don't think I've ever said this before, have I? If you can't integrate, this is a good one. If you can't integrate, give up and go cry in the corner. Yeah. That's not a good saying. The better saying is this. If you can't integrate, accumulate. If you can't integrate, accumulate. And when I say accumulate, I'm saying accumulate area. Right? Remember how we did that before? We've actually done this. Don't give up. Don't cry. If you can't integrate or you don't want to integrate, just accumulate area. So that's what we're going to do. I'm going to take a look at the graph here, and I'm going to figure out what these areas are, and I'm going to use that to help me. So I'm going to kind of chunk this out here. I'm going to make a little triangle with that. The dimensions on that triangle would be what by what? 1 by 3. So the area for that little triangle would be what? 3 halves, 1.5, yep. So I will try to squeeze that in right here, 1.5. All right. And of course, you can see that that area is below the x-axis. So when you actually integrate, it's going to show up as negatives. And then this other triangle right here, the dimensions are what? 4 by 4? 4 by 4. So what's the area of that particular? It's 8, yeah. Okay, good. So I've got those 2 areas there. So the way that I actually evaluate the integral on the left, I'm just going to accumulate area. Who knew? So all I have to really do here is say to accumulate area, I'm going to go from left to right. The first piece that I come to has an area of 1.5, but it's below the x-axis, so it's going to be negative 1.5 plus 8. I'm just accumulating. I'll try to get a little shadow there, just accumulating from left to right. I'm accumulating those areas, and because they're linear, they're very easy to find, and that will equate to my integral. So to finish this out, all I have to do is a little arithmetic, a little bit of algebra. So negative 1.5 plus 8 is 6.5. I subtract the 3, and I get 3.5. Divide by negative 1. I'm coming up with negative 3.5 is equal to f of negative 7. Did I do my arithmetic right? I think I did. So negative 3.5 goes right there. All right, so the good news is that's the pattern. The bad news is we need to do that 3 more times. But once you get good at this, you can actually go pretty quick. You really can. So would you guys like to do, would you like me to kind of guide you through another one of those, or do you think you have the hang of this? You want to do it alone? Okay, that's fine. So why don't you guys try this on your own, take a few minutes and do that. I'll give you, I don't know, 5-ish minutes, something like that, to try to get this one settled. Ready, set, go. You guys figure out the other areas yet? I got 6 and 4. So guys, what I'm going to do, hey guys, listen up please. What I'm going to do here, I'm going to just use that middle space for each of these, but I'll erase in between just so that I've got room for all this. Hey ladies, gentlemen, let's get started here. So my next goal is to find the output for negative 6. So I'm going to set it up as the integral from negative 2, or negative 6 to negative 2 of f prime of x dx is equal to f of negative 2 minus f of negative 6. One little thing I wanted to bring out that we were talking about over here, I would strongly suggest that with your limits on your integral for all of these, I suggest that one of your two limits be negative 2, simply because we know that that's going to always be correct. If you make mistakes, that mistake could be propagated throughout the rest of your table. So I would make one of your limits negative 2 every time, just like this. So the integral from negative 6 to negative 2 is, based on the area within the graph, is simply 8. We know that this is 3, and so I get this equation right here. Subtracting the 3, I get 5. Dividing by a negative, I come up with negative 5 for my output there. So thoughts or questions on that part? I saw that on a lot of papers. I didn't get a chance to see everybody's, but we okay? All right. We already know what's going on at negative 2, so my last two are going to be what's going on at negative 4, or excuse me, positive 4 and 8. So my next integral is going to be the integral from negative 2 to 4 of f prime. So notice that the location of the negative 2 just changed, because now the negative 2 is actually the lower number on the integral, right? I still want to accumulate from left to right. You can accumulate from right to left, but everything's just going to be backwards. I prefer to be consistent. So this is equal to f of 4 minus f of negative 2. The integral from negative 2 to 4 is negative 6. F of 4 is what we're looking for, minus 3. So I'm looking at this, and I'm coming up with negative 3 for that output. Looking around, I see totally calm faces with no questions. I'm right, aren't I? Okay, that's great. That's the hope for sure. Any questions? None? Okay. All right, and then the last one is when x is 8. So this is going to go pretty similarly. It's going to be the integral from negative 2 to 8 of f prime of x. That's going to equal f of 8 minus f of negative 2. Using areas once again, I'm coming up with negative 2 for that integral. And I got f of 8 right there, minus 3. So I'm looking at 1, 8 comma 1. So you hopefully had enough space. I didn't really have enough space on my screen here to do all of these. But what you want to do here for a final step would be to call out what the max and the min is. And so it just says find the absolute extrema. I'm going to say the max for f is negative 2 comma 3. That ended up being the highest point. And the minimum is negative 6, negative 5. So make sure you call those out and actually answer the question after all that work. Okay, again, I'm looking around and seeing a lot of calm faces. Does anybody have a question? Even a little tiny question? Nothing? Yes, Josiah.
So, I'm really confused on the way that you set up the integral, just because the first one we went from like negative 2 to negative 7.
Well, so the first one we did, I set it up, I think I did set it up like this. If I made a mistake, we'll fix it. But it should be negative 7 and negative 2. I always read from bottom to top.
Okay, yeah, that's what I was confused, because I wrote down negative 2 to negative 7.
Okay. Did I mess that up? If I did, I'm sorry. No? Right? I could have. I make silly mistakes,
So
unfortunately, all too often.
It's always just from left to right? You go like
I always seek to go from left to right.
Okay.
You can, so I was talking with Alexis about this. You could do it this way. You could say negative 2 to negative 7 on your limits. And that's actually totally okay to do it that way. Then this would equal f of negative 7 minus f of negative 2. But then what's weird is you're going to be accumulating the other direction, right? So what used to be positive would now be negative, and what used to be negative would now be positive, right? Because now your dx is negative, right? It's going to flip all those signs. And so I prefer to not do that, simply because I'd like to be consistent and have stuff below the x-axis integrate to be negative and, positive on the upside. That makes sense?
Yeah.
Okay.
Could you put a negative in front of the handle then to fix that?
Yeah.
Okay.
Yeah, if you went, yeah, you know what? That's actually a really great point, because you remember the property, flip the limits, flip the signs?
Right.
That's what you're doing. Exactly, yeah. All right. Any questions? We good? Okay, beautiful. Let's take a look then at our next example. This is the one, I think it's sort of a water tanky kind of a question. So go past the two sentence questions and go over here to Camp Newton. Yeah, Camp.
Wake up in a camp hospital or something. I don't know. You play football, but there's just a little fireplace.
Okay. So you can maybe, there's a part D you can see on your paper that's off the bottom of my screen. We'll get to that later. Maybe you can tell that this is an old AP question from back, I don't know, 6 or 7 years ago, something like that. It's got parts A, B, C, D. I picked this out because most of this has to do with this chapter. B, C, and D, I'd say, would be directly applicable to what we're talking about right here. A is actually a review question. It's actually would be from chapter 3 probably. I think it's good to always kind of pepper in review and spiral some stuff in, so I included it. And so I would like to kind of do this maybe one by one, right? So maybe if we could all just look at A right now. Like A is totally review. So you might need to do some remembering, but can I give you guys maybe like 2-3 minutes? Calculator active for sure. Calculator active for sure. Please try A. A says, is the amount of water in the tank increasing at T equals 15? Why or why not? So again, this is just review from chapter 3. And did you notice that there is a rate of water entering the tank, being pumped into the tank, and there's also a rate of water leaving the tank? Yeah, so this is the proverbial, net rate water tank question that we've looked at this sort of thing so often. So please consider, make sure you're in radian mode once you get to the calculator part, because that'll make a difference. For A, I'm not going to do the details in the calculator because I'm sure you all did that just fine. For A, what I would want to write down is this. W of 15 minus R of 15. Because W is the rate of the water being pumped into the tank. R is the rate of water being removed from the tank. And so this expresses the net rate. So did you guys do something like that? When you calculated that out with the 15, I realize it took you maybe a minute to get all that plugged in correctly. What did you come up with? Positive? Negative. Okay, so negative 121. Let's go 3 decimals just in honor of the AP people. 090. Okay. So we want to have the correct number, but what really is the most important part about that number? It's negative, yes. So we say less than 0. And the way the question was worded, it said, is the amount of water in the tank increasing? This is a yes or no question. So what's your answer? No. And your answer should be no. Therefore, no, because you could say the net rate is negative or something like that. And then you call this A prime. A prime of 15. Yeah, A prime of 15 is negative, sure, if you named it like that, no problem. Yep. Okay, so am I right? Does that make sense to you guys that is entirely review? Yeah. That's old stuff. That's from like section 3.3, I think. It's been a while. Okay. B, however, is very contemporary. It's right up with where we are. So B says, to the nearest whole number, how many gallons of water are in the tank? So I want to be super clear about this. When they say how many gallons, they're asking for an amount, aren't they? So they could say what amount of water in gallons is in the tank at T equals 18. I would just remind you about this. You were given R of T and W of T, both of which are rates of change of the amount of water. And now they're asking you for the amount of water. So if you're ever given rates and then asked for an amount, what are you going to have to do somewhere? Yes, integral. So please try B. Sometimes that's the worst kind. All right. Let's take a look at B. Please do slow me down if you have a question on this. It says how many gallons of water are in the tank at time t equals 18. Here was my thought process with this. I know that when t is 0, there's already water in the tank, right? So I'm going to start it off by saying, well, I know that at the very beginning there is 1,200 gallons in the tank. So I'm going to say 1,200 plus. Oh, did you guys forget the 1,200?
Yeah.
Well, let's talk about that. So let me fill this in real quick. So this would be your expression right here. This is super important that you get this, because once you do get it, it's going to open up the door on a lot of these and make them really easy for you. If all you have is the thing in the blue box, obviously you've done a lot of good work, but if all you have is the thing in the blue box, what is it that you've given? That's the change, right? That's the change in the amount of water, and I'm guessing from your reactions that is negative, isn't it? Oh, that's positive? Okay. Why you just didn't see the 1,200? Was that?
Just didn't add the 1,200.
Got it. Okay, fair enough. All right, so that's only giving the change, which is a good thing, but then to get the actual amount, you're going to need to add what was in there to begin with. And so I would say that this is simply the original amount plus the change. At this point, I would absolutely go for Math 9 and say 1,200 plus Math 9 of that right there. And I'm wondering, you guys have an answer for that? I don't have it memorized. 1309.788, and it did say to the nearest whole number, so 1310 gallons. We agree on that number? Good. Questions? Questions on the setup? Are you getting this net change thing? Are you seeing how this has just been, like the net change is just like over and over and over, just in different forms? Keep doing the same thing. Any questions from anyone? You got time if you got them. Okay, fair enough. Then I'm hoping that when you look at C, you see it's almost like that question we just did earlier, like the one with the line segments. Our methodology to getting to an answer is going to be a little bit different because we have the Math 9 thing available to us, but it's the same type of question. So please take a minute, take a look at C. It says, at what time t on the interval 0 to 18 is the amount of water in the tank at an absolute minimum? Show the work that leads to your conclusion. So please try. Take a few minutes and do this. Please extensively use your calculator.
No, we don't.
Hey, oh gosh, I'm sorry to interrupt. Can I remind you of one other thing? In B, if all you did was wrote this or wrote that, how many points you get on a test or the AP test? You get nothing. You need to include your setup, right? So all the things in the red boxes, one of the two answers there on the right, will get you full credit. If you don't have the thing on the left, you get nothing. So please include that. So we're looking at C. Ready, go. So in order to find an absolute minimum, you've got to consider endpoints critical numbers. Your endpoint's pretty obvious up there, 0 and 18. Critical numbers are a little bit less obvious. In order to get critical numbers, you need to do W of t minus R of t and set that equal to 0. You want to set your net rate equal to 0. And walking around, I saw most of you guys doing that on your calculators. Would you guys mind letting me in? I think there was two of them, right? So t equals what and what?
6.495.
And the other one? 12.975. So do we agree on those critical times? Okay, so I'm going to make a table. I'll just make my table over here. My candidates are going to be times 0, times 6.495, and 12.975, and 18. So of those four candidates, I actually already know a couple of them. I know that when t is 0, the amount of water in the tank is 1,200, right? And don't I know the amount when t is 18? Yeah. Didn't we just do that in part B? Was it 13? Yeah, 1310. So the good news is I already know two of the four. So I only have to do two bits of analysis to get the other ones. And here's the truth. We're going to have to use an integral, and here's why. The only information still, the only primary information we have is still just about rates. So if I want to figure out how much water is in the tank at 6.495, here's what I would do. So Zach, this is directly to your question. I would say that at the beginning there was 1,200, and then to find how much is in there, I need to add the change. So I'm going to go 1,200 plus the integral from 0 to 6.495 of W of t minus R of t dt. So that's literally original amount plus change gives me my final amount at 6.495. Does that make sense? We're using that net change theorem where the definite integral of a rate is equal to the net amount of change. And if I just add that to what was there to begin with, then I've got the amount that's in there at 6.495. Has anybody calculated that number out? Anybody done that?
For 6.495?
Yeah.
525.242.
525.242. We agree with that? Any agreement on it? That sounds about right, if I'm remembering this from way back.
Okay, so that's the thing that you add 1,200 to the...
Yep, that's doing the full 1,200 plus the change.
Yep, I agree.
You agree? Okay, awesome. So then, does it make sense on how we would proceed to the 12 point, whatever it was number, 12.975? We'd go 1,200 plus the integral from 0 to 12.975 of the same net rate in order to get the amount there at the 12.975. So, I'm assuming, yeah, Hannah, what do you got? 1697 point what? 44? Okay, so this asked for the minimum. It's not too hard to figure out what the minimum is. You just look for the lowest amount there on the right-hand column. So then you just want to call that out and say the minimum is 525. Did it say round to the nearest anything? Nope. So 525.242 gallons.
What's the time?
Oh, I wanted the time? Oh, at what time t? Okay. I didn't read the whole question. At t equals 6.495.
Do we have to write that second part in the test?
You have to call your answer out. So like if you, that part was unnecessary, but if you put this, I'm good with it. But if you just do this, if you just have a table, you really haven't answered the question. You said, here's some data, you figure it out for yourself.
Like, we can't circle the answer and, like, explain it, or is that...
Well, I mean, Matt's point is well taken. He said it asked for a time. So just doing this, it's like, I think that means your answer, but in some cases, maybe you wouldn't want that. Just write t equals 6.495, something like that. Circle it, just like draw it out of the table. Make it easy on the reader. Don't be like, haha, I'm going to make it a riddle. If you can figure out my riddle, you'll...
Sometimes it's like you
Don't do it that
throw a
way.
bunch of answers on the page, and then you circle a couple of them.
Please don't do that. Please don't. Okay. Hey, Jake, question.
Do you give points? Like, I just saw, like, when I was doing the graph, that 12.975 was giving me a maximum. So
You have to address all your candidates. You can't just ignore it. If you wanted to say at 12.975 the net rate goes from positive to negative, therefore that's a relative max, therefore it's not the min. If you want to write that out, I have no problem with that. But what you can't do is just be like, yeah, I'm not going to even acknowledge that that's a candidate. Acknowledge it somehow.
Okay, thank you.
Guys, I want to close this one off for you. Let's do this last one together. Hey, this won't take very long to do. This says for t greater than 18, so beyond the domain of what we've done so far, beyond t equals 18, the water being pumped into the tank is turned off. That stops. But the water continues to be removed at the rate r of t until the tank becomes empty. Let k be the time at which the tank becomes empty. Write, but do not solve an equation that you could use to find the value of k. So here's what we're going to do. What's the amount when t equals 18? Like how much water is in the tank?
1310.
So 1310 approximately. Okay. So remember, the W has been turned off, right? But the R continues. So what I'm going to do is this. I'm going to subtract the integral from 18 to k of R of t dt. Yes, I'm aware of the time, Mr. Clock Watcher. You should be thankful I don't watch the clock like you do when you're walking in late. Yes. Not you specifically, but you as a group. Yes. Always two sides to that same thing. You're usually on time, but other people are like, what? Oh, class starts then? I didn't know that. It's like, really? You've only been doing this for 4 months now. Okay, so what this is the amount at the end, 1310, minus how much was removed, right? But it asked for an equation. So I put equals what? 0, because the tank would be empty. So equals 0. And that's, thank God, all you got to do, because it just asks for the equation, where if you solved it, you'd get K. You don't actually have to solve that. You just say, that's the equation. Somebody else can solve it.